Hello everyone, I am Pushpak Pandit and you are watching me on my YouTube channel being Bookish. Okay, so before I proceed to my topic, let me tell you something. Previously, I used to upload videos on YouTube in a screen recording type of system, but from now I have changed my setup and this is what the new setup looks like. It is similar to those who upload educational related videos, but for me it is a new kind of thing. Okay, so this is what a new thing which I have generated just so that you can get connected to me. Okay, so let's start our today's topic. So our today's topic is how to find electronic configuration. Okay, so to deal with on how to find the electronic configuration, first we have to know what is exactly electronic configuration. Okay, so we will take some steps to solve the questions on how to find electronic configuration, but before that the first step is on knowing what is exactly electronic configuration. This is what I have written. Arrangement of electrons. Very easy. Arrangement of electrons is called electronic configuration. You will say, oh my god, such a short definition. Yes, you can remember this as a sort of definition, but it is not exactly a definition. See, you know that an atom consist of three subatomic particles. What are they? They are electron, proton and neutron, right? You know that electron, proton and neutron are the subatomic particles of an atom. Okay, now this word electronic, this word can come from which word? Electron or proton or neutron, means which subatomic particles looks exactly similar to this word. I think you must have guessed the word electron and this is right. Okay, this electron is related to the word electronic. Now you will say that how this word is connected with this. See, this is what you should look for. Arrangement of electrons. This three word contain a whole definition of these two word. Okay. Mainly electronic configuration is mainly deals with how the electrons is arranged in this atom. We are not considered for proton and neutron, we are mainly concentrated on how this electron, how this subatomic particle is arranged inside an atom. Okay, so I hope the definition is quite clear that in the electronic configuration we are generally going to discuss means how this electron is contained or how it is configured. What is configured means how it is arranged inside an atom. Okay. So after knowing what is electronic configuration, now is the main thing that how we are going to find the electronic configuration of any atom. Mainly if you are in class 7, 8, 9, 10, you have to learn the electronic configuration of first 20 elements. Okay, so I am going to give you few steps through which you can easily find the electronic configuration of any element. Okay. First, the foremost step is to learn. Okay, let me write here that you should learn the first 20 elements that is given in your book, or you can find it on the internet also. What I am talking about, like the first is hydrogen, then comes helium, then comes lithium. Like this, there are 20 elements which must be given in your book. Okay, so first learn these 20 elements. Okay, this is the first step which I am looking forward for. Now, second important thing, you are going to learn, but learn in sequence. learn all these in a sequence manner. Means the first comes is hydrogen, and you should know that the first is hydrogen. You should not learn like okay anything can come anywhere. No, you should learn in a sequence manner, like first is hydrogen, second is lithium, third is second is helium, third is lithium, fourth is beryllium, fifth is boron, and like this in a serially in a sequence manner. You all should learn this at least the first 20 elements which is required in class 7 to 10. So after learning the first 20 elements in a sequence and serial wise manner, why I am telling this to learn in the sequence and serial wise manner? See, I have written the first 5 elements. Okay, the first 5 elements is hydrogen, helium, lithium, beryllium and boron. Okay, we are mainly concerned about this serial number. Okay, this serial number is, in chemistry it is called atomic number. These are the first 5 atoms, and if I will ask you what is the atomic number of hydrogen, you will say 1. What is the atomic number of helium? You will say 2. Means whatever is the serial number of that element or the atom, that is only the atomic number of that particular atom. Understood? Whatever is the serial number of that particular atom, that is only the atomic number of that particular atom. This is what I have told. So to do the electronic configuration, we have to definitely learn these things in a serial wise manner. Okay, and this serial is called atomic number, and from now onwards you are going to use the word not the serial number, but you are going to use the word what? Atomic number. Okay, suppose I ask you what is the atomic number of boron, you are going to answer 5. Okay, now if you have a pen and a copy, kindly take it out and start noting from now onwards. Okay, first thing you should know, there are 4 shells. There are many more shells, but particularly to do the electronic configuration of first 20 elements, we need at least and maximum 4 shells only. What are they? K shell, L shell, M shell and N shell. What I am talking about? See, in an atom, this is a atom. Okay, suppose this is an atom. In this atom, the electron will lie somewhere. Okay, the electron will lie somewhere. This first is called nucleus. What is first? First is called nucleus. The first one is nucleus, and from second starts the cell. This is the first shell, which is also known as K shell. Okay, this is the second cell, and it is also known as L cell. And likewise, if I draw one more circle here, that will be the third cell, and its name is M shell. So in these cells, the electrons lie. Where the electrons lie? In the shell. So now you have understood that the electrons lie in the shell. But you know, if a house is small, then not many people can lie there. If a house is big, more people can lie there. Okay, so what basically I am trying to tell you is that in the first orbit or in the first shell, see, you can tell it as a shell or you can tell it as orbit also. This is also known as what? Orbit, and we can also call it what? Shell. So where the electrons lie? In the shell. In the first shell, now you should start noting. In the first shell, what is the first shell? K shell. In the first shell, only 2 electrons can live or 2 electrons can lie. Likewise, for the L shell, only 8 electrons can lie, and M shell 18 electrons, and for the N shell 32 electrons can lie. What I am trying to say is, in the first shell, you can see clearly, this is the first shell. This is not the shell, this is what? It is a nucleus. The first shell starts after the nucleus. So this is the first shell, and in this shell or in this orbit, how many electrons can lie? There can be only 2 electrons which can lie here. And likewise, this is the second shell. You can see clearly. This is the second shell, and in the second shell, which we call also as L shell, only 8 electrons can lie here. How am I getting these numbers? That in the first shell only 2 electrons, in the second shell 8 electrons, in the third 18, and in the fourth 32. Let me tell you also this in briefly. There is a rule which is called Bohr Bury Rule. What? Bohr Bury Rule. They gave us a formula of 2n square. This is the formula for finding what? How many electrons will lie in a particular shell. Here n denotes the shell number. Shell number. Okay, n denotes the shell number. Suppose how many electrons lie in the K shell? So K shell is the first shell, as I have told you earlier. So putting the value 1 here, we get 2 into 1 square is 1. So 2 into 1 is 2 electrons. This rule tells us what? How many electrons will lie in the particular shell. Okay, suppose we take L shell. Okay, what is the shell number of L? It is 2. Putting back in this formula, what we will get? 2n square is the formula. 2 into n is, n's value is 2. 2 into 2 square is 4. So we get 8 electrons. Okay, I think this is not clear here. So let me write here 8 electrons. Okay, so likewise for many different shells, we can count that how many electrons can exactly lie in that particular orbit or in that particular shell. Okay, so now as you have grabbed all the constituents which are needed to find the electronic configuration, but one more thing is still remaining. What is that? Suppose I will ask you to find the electronic configuration of first element, hydrogen. How we are going to do that? Means for any particular atom, you need how many electrons are there in the particular atom. Then only you can say that this many electrons can be arranged. Getting my point? Are you getting my point? Means I am trying to say that if I say you what is the electronic configuration of sodium, first of all your question should be how many electrons are there in the sodium. Then only you can arrange or do the electronic configuration of sodium. Okay, this is very simple. Suppose first one is hydrogen. Okay, what is this? This is atomic number of hydrogen. So note this very carefully. Whatever is the atomic number of that particular atom, that many electrons it contains. Let me repeat it. Whatever is the atomic number, that many electrons the hydrogen or that element contains. Means if I'll ask you what is the electrons, how many electrons are there in an hydrogen atom? So you will say that 1 electron. Likewise, after hydrogen comes helium. I will ask you what is the electronic configuration or how many electrons resides in a helium atom. Your answer will be 2. Likewise, again if I will say you what is the number of electrons in a lithium atom, your answer will be 3. Okay, so this is very easy to find the number of electrons in an atom. Okay, in an atom number of electrons are equal to its atomic number. Now it's almost clear and you are definitely ready to do the electronic configuration. So let's start the electronic configuration. So after explaining all the basics which are needed, now let us really start on how to find the electronic configuration. The first one or the first element is hydrogen, written as H. This is the short form or the symbol of hydrogen. What is the electronic configuration of hydrogen? Now, second question, how many electrons are there in the hydrogen? One. Okay, so this is what the representation. Here I will write EC. EC is what? Electronic configuration. Okay, so hydrogen electronic configuration is 1. What does it mean? That one electron will come here. This is the nucleus. You can't take the electrons in the nucleus. Okay, the electrons are present outside the nucleus. So outside the nucleus, what is it is present? The cells are present. This is the second cell, this is the third cell. Okay, so first of all, the electrons go and fill the first cell for any atom. This is an atom of hydrogen. Okay, so for a hydrogen atom, this is what the atom looks like. The first electron will go here. It will get clear as I will talk about helium. Helium has how many electrons? 2 electrons. So basically what will happen, the electronic configuration is 2. And let me draw one more circle here. I can draw it anywhere in this shell. In this particular shell, I can draw this circle anywhere. What does this circle represent? Number of electrons. And you should also remember that the first shell is also known as K shell. And one more thing you must remember, that it will contain only 2 electrons. Why am I telling this? See here. What is the electronic configuration of lithium? How many electrons are there in the lithium? 3. Okay. So the electronic configuration of lithium is 2, 1. Oh my God. Why it is 2, 1? Why it's not 3? Why it's not 3? Because it is illegal, that a kind of illegal thing we are doing. We are taking 3 electrons in the first cell, or in the K shell we are taking 3 electrons, which is not possible, because the K shell is telling that I can only accommodate only 2 electrons. Okay, so in the first cell 2 electrons will go and not 3. So but it has 3 electrons, it has to do something to make one more electron lie in the atom. So it will transfer one electron in the second cell, which is also known as L cell. L cell can accommodate maximum of 8 electrons. Okay friends, now let's see beryllium. What is the electronic configuration of beryllium? First you will ask, what is the number of electrons of the beryllium contains? 4. Okay, so number of electrons beryllium contains is 4. So first 2 electrons will go here. The first 2 electrons will go here. Where will the 2 electrons go? In this shell. Okay, so this completes the electronic configuration. So its electronic configuration will be 2. I forgot to tell you something, that this is orbital diagram. This is mainly the orbital diagram of particular atom. If you will be asked what is the electronic configuration, you just have to write this and not this. Okay, unless and until it is asked that you should also draw the orbital diagram, you are not going to draw it. Okay, very simple. You should only do this part. Now next question, what is the electronic configuration of boron? So very easy, we will find the number of electrons that boron contains, which is 5. So 2 here, 3 left. So 3 will go in the second cell, means here. Why in the second cell? The second cell can contain almost 8 electrons. So 3 can hold easily. Okay, but why can't it contain like 5? Not why it can't contain only 5 electrons in the first cell? Because the first cell can only contain 2 electrons. So the left part is transferred to the next cell. Okay, are you trying to understand? Now let us do few more electronic configuration of another elements. Okay, at number 6 we have atom of carbon. Now the question will be how to find the electronic configuration of carbon. So first question is again, what is the number of electrons of carbon? So number of electrons is 6. Okay, so how they will be distributed, how they will be arranged? First, the 2 electrons will go in the first cell and remaining 4 will go in the second cell. So we will write 2, 4. Great. Seventh one is what? Nitrogen. Nitrogen contains 7 electrons, so 2 comma 5. So 2 plus 5 makes it 7. I think you are getting it easily. 8. 8 is oxygen. Oxygen has 8 electrons. So how these electrons will get distributed? So it is 2 comma 6. The first 2 electrons will get into the K shell and left 6 electrons will get into the L shell. Now the ninth one is what? Fluorine. So number of electrons that fluorine contain is 9. So its electronic configuration will be 2 comma 7, because 7 can still be holded by the L shell. Maximum is 8. Okay. Now number 10th, only few more, just few more, is neon. Neon contains 10 electrons. Okay, so its electronic configuration will be 2 comma 8. The first 2 electrons will go in the K shell and the remaining 8 will go in the L shell. Now the 11th one is what? Sodium. Now how will you do the electronic configuration of sodium? See, the same concept we have to apply here also. Number of electrons that sodium contains is 11. Very good. Now the first 2 electrons will go in the K shell, so 2. How many remained? 9 electrons still remaining. So out of 9, the 8 electrons will get transferred in the L shell. 2 comma 8 means 2 plus 8, if you will do 10 electrons. Still 1 electron is remaining. So that 1 electron will be get transferred in the M shell. So its electronic configuration will be 2 comma 8 comma 1. So this is the electronic configuration of sodium. So now you must be getting the point of what actually I am trying to say, that you should distribute the electrons in these shells. Okay, so if there is excess of electron, you must transfer the electron in the next shell, like we have did here. It was containing 11 electrons, so what we did, 10 electrons get holded in these 2 shells, but 1 electron was still missing. It has to be done, or it has to be replaced somewhere, so it get spaced in the next orbit, in the M orbit. Okay, now let me do one more, and this is the last, magnesium. What is the electronic configuration of magnesium? It contains 12 electrons. Okay, so first 2 electrons will go in the K shell, remaining 10 electrons. So out of 10, 8 will go in the L shell. Okay, now still we have 2 electrons which are left. Now that 2 electrons will get transferred in the next shell, which is M shell, because M shell can accommodate maximum of 18. Okay, I think it is clear. It is 18. Okay, so it can contain 18. So we will write it as 2 comma 8 comma 2 is the electronic configuration of magnesium. Okay, so that's all for today, friends. I hope ki you got everything that you needed from this video, and you have learnt the basic concepts which are required to find the electronic configuration of elements. In the next video, I will try and make a video on the remaining elements, means from 13 to 20. Why? Because there is something else which I have to explain. Okay, so keep tuned and subscribe to my channel, and if the video is helpful, kindly like the video. Okay, thank you.